Hi, I'm Steve Logan, Xilinx's Analog Marketing Manager. Today we'll look at an overview of Xilinx's analog mixed signal technology, available in the Zynq 7000 all-programmable SoC. We'll start with an understanding of what Xilinx means when we say analog mixed signal, and look at the advantages of integrating analog. Then we'll close with a series of applications where AMS is a good fit for the Zynq 7000 family of SoCs. Zynq offers an unparalleled combination of analog, processor, and digital functionality. First up, we take a look at the block diagram of the Xilinx Analog to Digital Converter, or XADC for short. As shown with the gray blocks, the XADC offers a pair of 12-bit 1 megasample per second ADCs, a 1.25 volt internal reference, along with a multiplexer to measure up to 17 differential analog inputs from various sensors, voltages, currents, temperature, and light, 4 on-chip sensors for measuring internal temperature, and 3 voltage supplies are also included. And once you have your ADC measurement into the registers, you can use the programmable logic to do all sorts of cool things like filtering, calibration, oversampling, and linearization. The XADC is tightly coupled with the programmable logic, shown in yellow, and the processing system, shown in the green blocks in the gray background. And once you've integrated all the different functions with the Zynq 7000, there's no need to add an external ADC in many applications. Now let's take a look at why AMS is a good fit with Zynq for system monitoring and management applications. In many of today's applications, the need is growing to enhance the reliability, safety, and security of the system. This is mandated in a number of different applications and covered by a variety of industry standards. For something like communications infrastructure that requires high reliability and availability, a system that must function 99.999% of the time requires effective environmental monitoring. For security and anti-tamper protection, the XADC plays a key role in Xilinx's Security Monitor IP. Industrial applications that require high functional safety, as mandated by IEC 61508, will see the value of XADC's system monitoring. And you can do all of the system monitoring and management through the JTAG connection in ChipScope Pro before you even configure the Zynq device. The programmable logic handles the anti-tamper, first-level safety monitoring and signal processing, and the processor system, or the PS, performs the user interface, network management, second-level safety monitoring, and more. Next, let's take a look at how AMS is a fit for Zynq-based motor control. You've got a few GPIOs in the programmable logic controlling the drivers of the power stage. From there, we have the voltages and currents coming from the motor, where multi-phase signals typically need to be sampled simultaneously. As mentioned earlier, the XADC offers a pair of 12-bit 1 megasample per second simultaneous sampling ADCs, and these can be synced with the GPIOs on the PL side. Once you've got the measurements into the programmable logic, you can run a variety of digital post-processing techniques, like Clark and Park transforms, to give you the highest precision motor control system. Then the processor system monitors and controls the PL motor control loop. AMS is also a good fit for HMI resistive touchscreen applications found in various industrial, medical, and automotive systems. Here, the XADC measures the X and Y coordinates with differential sampling. You can use the digital IOs to excite the panel, and again, once you get the XADC measurement digitized, you can do the control and processing algorithms for various filtering and enhancements. And the PS can be leveraged for the user interface and touchscreen calibration. Sensors are another application where the combination of Zynq plus AMS can make a good fit. You can digitally control things like programmable gain amplifiers to enhance the performance of bridge sensors. Zynq's DSP slices and programmable logic allow you to pull a lot of the analog signal conditioning and filtering into the digital domain. Now you can efficiently perform functions like decimation, filtering, linearization, and calibration. On the PS side of the device, functions such as user interface, network communication, parameter setting, and measuring of the control loop can all be efficiently implemented. Following on the sensor application from the previous slide, AMS lets you achieve the classic integration value proposition of saving space and cost by integrating both the ADC and the analog signal conditioning. This example details a real industrial automation example for measuring an RTD temperature sensor, as shown in the top left corner of the diagram. After the RTD, there's an initial op-amp and a DAC for calibrating the amp's offset air. From there, you have an active filter, some passives, and a discrete ADC into the processor. By using Zynq and AMS, You can eliminate the DAC, second amplifier, external ADC, and greatly simplify the analog conditioning. Now inside the Zynq device, you can perform decimation, filtering, linearization, and calibration. In summary, the combination of analog, processor system, and programmable logic saves space, cost, and power. The tight integration enables better on-chip measurements. The processor system enables the user interface, networking, safety, and redundancy, to name just a few. And the programmable logic extends the basic 12-bit ADC by efficiently handling tasks such as system monitoring and integrating the analog signal conditioning in your processor system.